Hi, I'm Afshin Shaboni. In this video, I will show you how to connect HEC-RAS 2D and WASP model to simulate sediment and contaminant transport during floods. So why we are linking HEC-RAS 2D and WASP here? As you can see in this picture, flooding can ease the transport and redistribution of the contaminant across the floodplain. So in this case, the spilled oil from a damaged tank is being transported within the flooded area. So by linking HEC-RAS 2D and WASP, we are able to simulate transport of a chemical, especially contaminated soil and sediment during flood events. HEC-RAS 2D and WASP are open source software programs specialized in flood and water quality modeling. Here we link two models in an offline or one-way direction using an external coupler. So the coupler provides the computational grid, flow, volume, depth, and velocity data from HEC-RAS to WASP for sediment and contaminant simulation. So in addition to this data, coupler also allows for aggregation of the hydrodynamic data across both spatial and temporal distributions. If you are interested to learn more about this topic and especially the linkage, you can read my paper published in the Flood Risk Management Journal. For this linkage, we are using WASP version 8.5 that was recently released by EPA. So you can download the most recent version of the model from the EPA website. You can also download the external coupler from the FloodTalks website. To link HEC-RAS 2D and WASP models, you need to first activate cell volume and phase flow outputs under output options in your HEC-RAS model, and then you can save and run your simulation plan. For this tutorial, we will use the example file that is located in the external coupler folder. In this example, HEC-RAS model is set up using a flow hydrograph for upstream, an internal boundary condition, and normal depths for downstream boundaries. So the second outlet actually is blocked by a road and does not have any outflow, but I have included here to show you how to link a HEC-RAS model to WASP with more than one outlet. So you can export your HEC-RAS 2D computational grid shapefile for WASP simulation under the Geometry tab. Next, you can run the external coupler within the program folder. This may take a minute to run. Here we will perform a one-to-one linkage and use the HEC-RAS computational grid for both models. However, you may choose your own WASP grid if you prefer, and the program will align the WASP grid to HEC-RAS grid if they are different. Next, you will select the HEC-RAS plan output and the output folder to write the linkage file. WASP uses a standard unit for its simulation. So if your HEC-RAS unit is in English, don't worry, you can convert it in the coupler by selecting the English unit option, and the linkage will do the conversion for you. WASP does not simulate dry cells, so you need to specify a minimum volume and depth for dry cell. If you plan to simulate change in surface sediment, you need to select option 2 under WASP layer and define an initial depth for your sediment layer. You can also input variable depths and volume for dry segments using a CSV file and filter flow using the low bypass flow filter. The HEC-RAS flow output is typically noisy, so it is recommended to use the adjust flow option to correct the flow. This method adjusts flow for the WASP simulation while foreseeing cell volumes for the model. Next, you need to select downstream boundaries in your model. The coupler reads the simulation dates and computational time step from your HEC-RAS output, but you can aggregate the hydrodynamic data by simply applying a time multiplier. After running the linkage, you need to copy 2 files that contain your hydrolink names. These are one hydrolink.ctl and second hydrolink.txt. You also need to copy segment-name.txt. The program also generates WASP segments for mapping and future reference. To create linkage, you can paste the selected files into the WASP folder, then run the hydrolink application within the folder. This should generate the input linkage for WASP model. Now that a linkage is generated, you can start the WASP model and import the hydrolink using the dataset parameters icon. The program should successfully import the linkage and report the hydrolink statistic on the main page. Next, you need to save your WASP project. Here, we will select mass check as the output to test the linkage and ensure that volume and flow continuity have been preserved for WASP simulation. You can change the WASP output to an hourly time step under parameter dataset where you imported the linkage. Then you can activate related parameters under the constant group. WASP simulates a variety of chemical and water quality constituents under state variables. We will discuss this in future videos. For this tutorial, we will add a conservative tracer as our state variable for this simulation. You can now save and run the WASP model. During the simulation, you can check the mass value and state variable values. The mass value should be close to 1 to ensure the results are accurate. This concludes our simulation. I hope you found this helpful, and please don't forget to subscribe for future videos.